everybody. Good morning, ladies and gentlemen. I'm new International Marketing Director of CemPower. So I will introduce one typical project of WHR project. So this is the traditional steam running cycle. My presentation consists of two sessions. One is brief introduction of our company. Second one is introduce this particular project, which is Cement, located in UAE. We recently finished this project. Our company, they have changed name, I think 2 years ago. Before that, our company name is NTK, short name NTK, Nanjing Trans Kaser. It's well known around the world, but during the development, we changed our name from NTK to NKK. NKK short name, Nanjing Kasen Cannon. We are a subsidiary company of CMPA. So, established in 2005. Since our establishment, we already finished over 210 projects overseas, and also including the domestic. So we are only focused on capital power plant, waste heat and recovery power plant. That's our major field. We only focus on this, nothing else. So total installed capacity is 2,300 megawatts, including WHR projects. Annually power generation is up to 15.3 billion kilowatt hour. This is our capacity we install. The majority of our install is building material, this industry. Building material including cement industry and glass industry. So WHR can apply to the glass industry. And the second major field is metallurgy industry, which we can use in steel industry. WHR can also apply to sintering process, capture the waste heat, and also for the captive power plant, we 40% of is captive power plant. Captive power plant can apply to isolated grid of cement plant. Like usually the cement plant is in isolated grid. There's no connected grid, so usually we set the captive power plant plus WHR. Also, captive power plant can apply to steel industry. They can use the blast furnace gas, which is carbon monoxide. So we capture that gas and the body in the boiler, and that's the boiler generate electricity. So we should also include the CP. This is our reference list. Majority is cement industry and glass industry. It's domestic marketing for our achievements. This slide introduces our overseas projects. We have 12 overseas projects so far, 5 projects in India, 3 projects in Turkey, and 1 project in Saudi Arabia, which is City Cement. 1 project in Madagascar, Africa. 1 project in Mongolia. Mongolia project is a very typical project. They have CFB boiler plus WHR. And 1 project in UAE. And another several projects were commissioned overseas. This is the capacity of waste heat and recovery power plant capitalized in countries. This slide tells our revenue, sales revenue. As you see, our revenue, since established in 2005, the sales revenue grows quickly. And this potential, this consecutive years is stable, very stable. This is our customer we served. Part of the customers. Lafarge, Lucy, Heidelberg, and I think most of them is from CMPM or CemPower. Some of them is from another big giant country. Besides our project we are involved in, we also doing the BOT plant in China. We have several BOT plants in China. This is 4 of them. We build them and operation and transfer to the customer in certain years. Okay, after that, the second portion, I will introduce this typical project. The Sadia Cement factory in UAE. This is the picture. It's taken from the SP tower in 92. This is the air cooling condenser. It's very big. 3 cells. It's the turbine house. That's 91. This is 91. 91 they have one boiler, AQC boiler. They have another boiler which is out of the range of this one. It's 91. 92 is somebody stand on the 92 SP tower and take a photo. This cement plant including 2 production lines. Line 1 is 2,233 tons per day, and the line 2 is over 4,000. So we are an EPC contractor, signing project with customer directly. This system including 4 boilers, 1 turbine generator set, 3 ACC condensers units, and auxiliaries. It's the basic of design. Usually at the initial stage of the project, NKK sent engineers to site to take the measurement. This is the first step. Measurement taking is very important. It will give us the parameters to design a system. But because each system is customized, it's different. So we measure the temperature of flue gas, we measure the volume, we measure the pressure in the flue gas, and we get that data. We also connect the information of the historical records in the system, in the DCS system. So we make the final parameters along discuss with the customer. They can verify this is the minimum. We also get the raw water parameters which we use for the steam. So the raw water parameters is very important because our plant is designed by this one. So it's designed by these parameters. The power supply parameters is on this table. Because different frequency is related to the different speed of generator. 16 Hz related to the 3,600 RPM generator. What's the expectation of the customer? The customer was expecting a team-based optimized system with maximum power output, minimum water consumption, advanced automation control, reliable power distribution and a minimum construction period. NKK, we visited this customer, I think, at least 3 times before pre-study, and submitted the proposal several times and discussed with the customer. And also customer choose several suppliers, potential suppliers. One is from European, another is from India, 3 from China. And then shortlist to 2. And after visit to China, and then make final decision to choose NKK as the EPC contract. And this contract, they don't use consultant. It's very expensive. Usually for a cement company, the normal procedure, they want to hire a consultant and then doing the bidding process. But this customer is very special. They don't want to use a consultant. They think they can do it, they can learn for WHR, even they don't know at all for WHR, but they can learn. Another thing they think if they choose the reliable WHR provider, they have this capability much better than consultant. This is their thinking. So for this particular customer, they didn't choose any consultant. System process. So this system we designed including 4 boilers, 1 to 1 generator set. The 1 generator set is rated is 9 megawatts. It's used ACC condenser. The calculate the output is 8.5 megawatts against the ambient temperature 27 degrees C. But we give them 9 megawatts. So we have margin for this system. We also have margin, we also have update the generator. The generator we give this customer 10 megawatts generator. Because in particular period they can give more volume of the flue gas, which means they want this system can generate more power. Just the parameters we choose high pressure, and normally we don't say high pressure, but in WHR we say high pressure. But in power plant, it's very low pressure. But in WHR system, we then want high pressure. This is dual pressure system. So all the 4 boilers, they have dual pressure system. High pressure is designed at 1.27 megapascal. And the low pressure is designed by 0.18 megapascal. Because dual pressure can maximize the utilization of the waste heat and increase 5% additional output for the system. But will cause the large exchange area, which means increasing the weight of boilers. These boilers make bigger one. ACC is adopted to reduce the water consumption because this is a lack of water area. Air cooling condenser, shortly. So it takes approximately 85% of the total consumption of that project. It's in Middle East, lack of water. We have to choose ACC for this particular project. Also, they have cooling water system for boiler standing and the TG building patient equipment designed as closed circulation with a cooling water tower and the makeup water tank. It's also for the purpose of water cooling, water consumption reduction. So for our plant, we designed 2 stages of our plant because they have high mineral content. We also use the online sampling system, which is SWAS system. to reduce the manpower of the testing of the quality of water, of the steam. So this online testing. It's not very common use in China, but overseas we put this system. SWAS. Because this slide will use a lot of details for this project. The price based on the selection of the subcontract. Boiler, we choose the Hangzhou boiler. It's our long-term strategic partner. It's the best one. I think it's the best one for WHR, traditional WHR boiler. Turbine we choose Qingdao. ACC we use GA China because they have manufacturing in China. Generator we use Nanyang because customer ask a special requirement. They ask a VPI. So there's only one manufacturer in China that can manufacture this generator. This size of generator, which is Nanyang. High voltage panel use ABB. Every panel use Siemens China because they don't know much about the Chinese local brands. They only know ABB, Siemens, or Schneider. They have manufacturing. DCS system use the most advantageous system. ABB 800XA is the most advantageous system for the DCS system. Usually for this DCS system, 800XA is used a big power plant, but this particular customer asked this. The other auxiliaries use the Chinese specs. This is one photo for the AQC boiler because our for the technology of our company is different with other WHR suppliers. We use the settling chamber, which is used. This is our patented design. This is our patented boiler. Cannot see other else can use this. This is our patented boiler. The settling chamber, internal settling chamber. We don't use outside pre-dust chamber. We don't use the pre-dust gravity reduction chamber. Or we don't use the signal pre-dust signal. So we use built-in. This one. Obviously, they have more advantages for this kind of technology. The less loss of temperature, less temperature drop, and also save the space. Save space. It's middle tapping for the AQC boiler. For this particular plant, because AQC 1 we use the middle tapping. For AQC 2, we didn't use the AQC middle tapping. AQC 2 we have enough temperature for AQC 2, so we use external dust. We connect the waste heat from the external dust. But for the AQC 1, the 9-1, the temperature is not quite high, so we use the mid tapping to have higher temperature of the AQC. This photograph tells us the pH boiler. This is pH boiler. It's for pH 2. It's for 4,000. It's a harmony system in the harmony system for the pH 2 and the yearly reaction stage. This is pH 1. pH 1, this boiler is quite unique due to space limit and the preheater and insufficient jet pressure in the filter side. pH boiler is designed in such a way that it goes into boiler from bottom. The flue gas from bottom, they go in up, and this is outlet gas. That one is inlet, so it's a U shape. U shape. This is the turbine during the installation. During the installation of turbine, we sent 2 experts to monitor the installation of turbine, because for the C-portion company, they are not familiar with the auto assembly turbine, because this turbine is assembly on site is piece by piece. So we sent 2 experts and do it all by ourselves, and also ask them to give us several workers' help. This particular photo is for ACC units. There are 3 units. Units 1, 2, 3. It's each size. Each size. The customer wants to use the GA because they think GA is more famous than other Chinese brands. So even they visit China several times, but they still insist on choosing GA. So we finally choose GA. And this GA design is very special. It's very special. They use the vertical delta shape unit. This also shows the yearly erection of ACC. It's delta shape. This is the this is the change bottom. Heat exchange bottom. The total height of this ACC unit is almost 20 meters high. The length is 16 meters. It's our plan. This detailed information for the generator is 10 kilowatt. Usually for the generator, they have margin for 5%. It's typical. Brush is excitation system. It's box generator. This photo shows the electric panels for this system. High voltage use ABB China. It's the largest manufacturer of ABB group particular for the high voltage switch panels. LED panel we use Siemens 8PT model. This photo shows the generator excitation panels, signalization panel, and the relay protection panel. It's located in the central control room in front of the operator's desk. This CCTV monitor the level, what level of the high pressure drum and low pressure drums. This is our instrument and control system. DCS panel and the field instrument. The total EPC period is 15 months, and the construction duration is 12 months. It's very fast for this project. This contract signed, the counting time is once we receive down payment, and the finish time should be within 15 months. And we made it. We made it. This is the farthest project outside of China, the world. Some special photos shows this project. It's during the construction of the PH2 civil construction. That's another view of the power plant. This is the back view of the PH2 foundation. This slide shows the night, during night, what looks like the boiler. We use the steel construction for the TG building. This is for the testing, electric testing, because during the commissioning, they have to do the electric testing. Electric testing. Destuffing of the components from the logistic. This group photo of NKK and the suggested staff upon completion of the project. Guaranteed test result. It is all past the guarantee point, so around 352 kilowatt. In Middle East, they have, in Saudi Arabia, they have one project already finished. I'm talking about the Middle East. And in UAE, they have, this is 5 projects, big projects in UAE. And the 1, 2, 3, 4, and the finished by other companies. This is only they can meet the guarantee point. And this is the PAC certificate. It's issued by the CEO of Saudi Cement. After sales service, because beside this project, we finish on time and very satisfied with customer. So the customer asked us to, can we offer the operation service? We said yes, we can, because we have several BOT power plants, so we have staffs, so we have operators. So we send 9 operators to site to run this project and train the operators from such a cement for 1 year, at least 1 year. This is a group photo for operators. CO2 emission. So conclusion for this project, the first WHR power plant project out of China. In China, we can finish the project typically 9 months after signing contract till synchronization of the WHR. 9 months. So for overseas production, it's a little bit difficult because they have a lot of communication. They have a lot of technical discuss, also logistics distance. So, second point is successful WHR project with overpass the guaranteed output. Third one is steel structure of TG building will reduce the project period. This is very important. If you want to reduce total project execution, you have to think about this steel structure. They can at least save 2.5 months for the TG building. Very low self-consumption of the power plant. Even we use ACC, air cooling condenser, for this power plant, the typical self-consumption is 9%. But for this particular project, self-consumption is 7.48%. It's very low. It's very low. So, because for the point of view from the customer, the customer always ask the net output, not only your gross output. Net output is key. It's very, very important. So you have to minus self-consumption of the power plant. Thank you. Appreciate it.